extremely sorry, first of all, for the slight delay starting the meeting. Nevertheless, a very good morning, everyone. I, Dr. Kinkor Saha, along with Dr. Shirshendu Das, on behalf of Department of Physics, Uluberia College, warmly welcome you all to this national webinar on emerging issues in physics, organized by the Department of Physics in association with IQAC Uluberia College. Gratitude to the reverent presence of our respected principal sir, Dr. Devashish Pal, our respected IQAC coordinator, Dr. Aditi Bhattacharya, our honorable resource persons for today's webinar, Professor Dipak, Kumar, Goswami, and Dr. Sabyasachi Ghosh, all sirs and madams, our researcher friends, and our beloved students. As the sand clock of the universe started its journey of finding way from one hemisphere to the other, human race remained perplexed at the apparent mysteries nature unfolded every moment, aptly expressed by Werner Heisenberg as, not only is the universe stranger than we think, it is stranger than we think. Penetrating this Mexican hat of strangeness, trying to quantum tunnel the dynamics of non-linearity, nature serves us in our daily platters. Physics, the broad latitudes and longitudes of this subject helps us to trek through the contours and potential wells. At different layers of the subject were understood in more detail, we obtain verifiable and testable answers to the jigsaw puzzles nature riddles our minds with. This stabilized our intellect to create scientific theories and inventions for the greater benefit of mankind. The goal of physics is not only to observe nature, but to understand it. As quoted by Heisenberg, reflecting his words, in attempt to reduce the uncertainty of comprehending the surrounding phenomena, there have been a number of emerging issues which occupy the cynosure of our eyes. In this regard, it will be noteworthy to mention the role of nanoscience, related technologies, flexible electronics, having tremendous applications in various fields, including the domain of medical science as well. Turning to a different leaf, the regime of nuclear physics is as wide-ranging and relevant today as even before in the century-long history of the subject. Modern detector setups are giving us opportunities to explore phenomena at the femto scale right up to the astrophysical scale. With this, let me now have the pleasure of requesting respected Principal Sir, Dr. Devashish Pal, Principal, Uluberia College, to kindly preside over the webinar and to adorn the occasion with his precious words. Over to you, sir. Principal Sir?
No? I am now audible, right?
Yes, sir. You are audible.
Okay. Good morning, everybody. It's really it's my pleasure to welcome Professor Goswami as well as Professor Saha. Professor Ghosh and Professor Goswami to our college, Uluberia College. Today we are going to organize the modern perspective of the physics. So on behalf of teachers, all of my teacher colleagues, teachers, students and administrative staffs, we are all welcoming all of my guests. It's very interesting today. My students as well as all my colleagues who were attending, who registered this webinar today. It's a physics, so we know very well. We know from my childhood, at least I know from my childhood, the two names. One is Satyam Ghosh, another is Dept Saha. Who knows the physics, the stalwart of the physics. And after that, though I am the biologist, nowadays it has been established to everybody. So there is no stream of science practically. We know the science, the physics is the knowledge of nature, energy and matter that we know. But in our biology also, when we try to figure out all aspects of the environment as well as ecology and the interactions or interrelations between the matter and the living as well as non-living matters, and nowadays everything can be explained through physics. So really it's a very challenging. Nowadays in our world, I'm talking far from the country due to my personal issues. So it is very clear. It is very clear that nowadays physics is really it's a branch of biology, or biology is a branch of physics, whatever it may be. We people of physics, using the physics, we want to figure out the relationship between the nature and the matters. That is our motto. To our students who are of first semester, second semester, third semester, whatever the semester, that's too small. But I feel today's webinar has a direction, has a motto, has a motive, has a demand in mind, has an expectation in mind. Why and how will use my today's webinar? So we organize with a beautiful flyer. There is an organizing committee, 2 coordinators, IQAC coordinator. These are all parts of this webinar. But we want to figure out to the students as well as to my teacher colleagues that what will be our take-home lesson today. Whether our students will be motivated, or whether any question will rise in the student's mind for the future perspective, what is going on in the nature today. There is plenty of development, I believe. I am confident today's reputed and very successful professors from IITs. So they will explain, and at least explanation create the question in our students' mind of Uluberia College. That is our expectation. So thank you very much again. Today's webinar will not only satisfy, but raise some question in our students' mind as well as teachers' mind for future endeavor, and successfully it will be completed in the right way, in the right direction. Thank you, Kinkar, again, and thank you to my colleagues. Once again, last but not least, I welcome again all those Professor Goswami and Professor Ghosh. Thank you so much. I appreciate.
Thank you, sir. Thank you so much. Thank you so much for your ever-inspiring words, sir. The interconnections among the branches of science you discuss is truly something that we are looking forward to. Thank you so much again, sir. I now request Dr. Aditi Bhattacharya, Coordinator IQAC Uluberia College, to kindly share her thoughts with us. Madam, you can hear me, madam? Yes.
Good morning, everybody. Am I audible?
Yes, madam. You are audible.
On behalf of IQAC Uluberia College, I will welcome everybody who have joined this national webinar on emerging issues on physics. This is really a very interesting topic, as we all know that the never-ending wonder of the universe is being explored by the physicists all over the world. And I think the students of our college will be greatly benefited by this webinar organized by the Department of Physics in collaboration with IQAC. I welcome Dr. Dipak Kumar Goswami and Sabyasachi Ghosh, the eminent physicists who have kindly agreed to speak on the topic, and I thank my colleagues of Department of Physics for organizing such a beautiful seminar. We are really waiting with great expectations, and I thank everybody again on behalf of IQAC. Thank you all.
Thank you, madam. Thank you so much for warmly welcoming all our participants and our resource persons. Thank you so much again. So with this, I think we can now move to our technical session 1 and welcome Professor Dipak Kumar Goswami as our honorable resource person. Professor Goswami has completed his PhD from Institute of Physics, Bhubaneswar. He was then associated with European Synchrotron Radiation Facility, France, Northwestern University, USA, Max Planck Institute for Metals Research, Germany, for his postdoctoral research work. He joined IIT Guwahati in July 2007 and worked there as assistant and then associate professor. In December 2013, Professor Goswami has joined IIT Kharagpur. Sir has research interests in the fields of flexible and stretchable organic electronic devices, organic field effect transistors, bioelectronic devices, X-ray physics, nanoscience, nanoscale sciences, and so on. Professor Goswami has numerous publications in various peer-reviewed journals, and the number is still counting. He has delivered over 50 invited talks. He has contributed in number of books. He also has various sponsored and consultancy projects under his name and involvement in technology development in startup incubation under the brand name of Senflex Innovation Private Limited. Sir also has a list of patents filed under his name. Today we are extremely delighted and thankful to have Professor Dipak Goswami amongst us. We warmly welcome you, sir, and request you kindly to start your lecture. Kindly take over, sir. Dipak, sir, you can.
Yeah.
Yes, sir.
Yeah. Thank you so much. Thank you so much for inviting me to this workshop. And I also thank Professor Devashish Pal and Sir Aditi Bhattacharya for the introduction. And yes, as Professor Pal correctly said that when we were a student, actually, we had distinguished science between pure science and unpure science. Actually, like the bioscience, we were thinking that pure science is physics, chemistry, mathematics, and bioscience is something different science. So actually, it's not correct. So it's like all science, and you see that there is no barrier between any of the science. So they are all something that we need to work on. They are all science. So still, I know that many of our students and parents have this kind of understanding that my son or daughter should work on pure science after higher secondary or master's. I mean that shouldn't be the case. Okay, so it's all science. There is no distinguish things between these science. Bioscience, in fact, being a physicist, I would rather emphasize that the bioscience is like science of how so many things are still unknown, and we all jump into the bioscience region to understand physics, chemistry, and other branch of science. So that's really true. So today, what I plan is I'll be talking about some of the things that we work between physics and healthcare, which you already know that is basically the bio, right? So in this interface, so kind of work that we did in last couple of years, and I'll try to emphasize that starting from very fundamental physics, which you all know, how you can push your understanding and the research work into a technology which will be actually useful to mankind. I mean that is the part of discussion today for mine. So let me share my screen, and I also request the organizer. Sometimes when I will be in the full screen mode, I will not be able to see the background, and due to this internet connection problem, sometimes get disconnected, and I keep on talking. So if somehow I got disconnected, please instruct me to stop, or just mail or call me in my phone such that I can disconnect. So with that, let me share. Is my screen visible?
Yes, sir. It is visible.
So I switch off my video, save some bandwidth. screen is visible, right?
Yes, sir.
All right. Right. Yes. So thank you once again for the invitation. And so what I'm going to talk today is to actually take you through the journey that we had from lab to some of this technology that we have developed, which are essentially targeting the rural healthcare. And I'll be talking about some of the devices also. Like they're all flexible electronic devices, and how these devices that we fabricate in the lab can be used for medical treatment. So we have been working for last several years, and recently we have developed a medical device, which is medical intervention or diagnostic intervention, which is called a spirometer. So we have developed a smart spirometer, which is, as you see here, it's actually it's a final form, and it's already in a medical clinical validation trial. We started the trial. We have a startup also, so hopefully these devices will come to market and very soon. And this is a affordable system which can be used at home to address some of this pulmonary disease related issues like COPD, asthma, and then sleep apnea. And as you see here is we have been working for several such systems. So one of the systems that's T, which I'll be talking today, but we have the sleep eye, which is basically addressing sleep apnea, and then Senflex OFM. So that's like controlling and regulating oxygen flow when you actually some patient actually requires oxygen, supplemental oxygen therapy. Then emergency medical system. So these are the things that we are working on. But remember that these all things started from very fundamental things. So I'll be just trying to take you through that journey. What we do. So what is flexible electronics? So the flexible electronics is essentially a device which can be which is flexible. So flexible in the sense it can be stretchable, you can twist it, you can bend it, but still the device works. So this all started a decade back, and as you see this title, which is essentially reported by Professor Bao from Stanford University, 2008, and she talked about stretching our imagination. But essentially, it's a flexible device. But what I found interesting here is the title, that imagination is something that has a limitless stretching capability. So you can stretch at the highest level that you can think of, other than any physical device or anything. That it has everything has a stretchable limit that you cannot stretch beyond that. But the imagination is something that you can stretch to any level, right? And it's very important to actually stretch your imagination, because the invention, discovery comes from imagination. So what you actually imagine today, it's the reality in tomorrow, right? So you need to really stretch your imagination, particularly all the students, who are working in science, and I'm not talking about only the physics, but science in general. You need to close your eye and sit and then imagine, and you think what you can do in communication. Okay, so this paper, of course, talked about single or carbon nanotube based flexible and stretchable electronic devices, and I will talk some of them here for different aspects. Flexible electronic devices, there are many already applications which are already in the market. As you see, perhaps many of us having this Samsung Fold, right, mobile phone which can be fold, right. So the display that is there is actually made of flexible electronic device, and which can be folded. And nevertheless, there are many other applications see in the market, these are all made of flexible electronic devices. Now, what is our idea is not to work on this kind of device, but you utilize these flexible electronic devices to address different kind of fields. Now, as you see here at the screen, I have this button is blocking some of it. So what we have been working is essentially on healthcare devices. For example, you see the flexible temperature sensors, and then it's like a matrix of sensors. So to continuously monitor the body temperature, wireless. So these are the device temperature sensors, flexible, and then there are other sensors also. We have like pulse monitoring system, pressure monitoring system. So these are the different type of healthcare sensors that we have working on. Now, just to motivate students that many of you think that what is the point of going through this kind of studies like science, mainly the taking the science as a background, right, observations and future. You see, rather than the science, this also has some kind of the applications which is a huge market. So if students who are thinking about getting a job and earning money, so the research is also no less than you can have you can translate your research into technology, and there is this market, particularly in case of medical device market. So I just give you some numbers. So you see here that there are medical devices. Right? So this is for sports and fitness, remote patient monitoring, home health care, and this it's a very huge market. So this is the prediction, as you see, up to 2026. The market is growing something like 26.1%, and this one is mainly targeting to the US wearable medical device market size, which is something like in 2018 it was $10.3 billion, but now of course, as you see here, it's increasing of the rate of 26%. In addition to that, this is again another prediction that what are the things that particularly in this wearable medical devices, what is the market and what is the future. As you can see, these are the areas where we need medical devices, and of course it has a huge market. As you see, in 2019, which is more than double in 2022. Right? So next 2 years, this is the market will become about 20 billion. So what we do with this introduction, so what we do, let me start that what we have done in this case, we actually targeted IoT. So IoT is Internet of Things, and what exactly it means is that you have junction which we call cloud, and all the things that normally, like everything, anything and everything that you use today, right? So those are all things which are connected to a center which is cloud, and everything can be operated through cloud, through your mobile app or somewhere some central facilities. Everything is connected. For example, your smart retail, which are already connected, smart home cities, right? Wi-Fi, embedded electronics, IoT in agriculture, and then most importantly, vehicles, asset pets, monitoring. So everything are, some electronic devices are connected to them, and these devices are connected to a this, the IoT, we can think about something called IoT. So IoT is Internet of Things, Internet of Medical. So similarly, we can also connect all these medical stakeholders together, right, in same cloud, such that everything can be controlled from a single thing, right? Because life will be much more easier, like home care, and then your primary care, emergency service, secondary service, hospitals, right, clinics. So everything is connected then, and you think about like you're traveling in a car, suddenly you feel some issues in your health. Immediately all the stakeholders can be connected and proper action will be taken in moment of time. Right? So that is called IoT. So your electronic device, particularly the diagnostic device and all other like emergency services, right? So they can be all connected to the same mobile app which will be carrying with a small system, right? And doctor can monitor from the clinic. So the doctor needs not to come to your place, or you do not need to go to visit the doctor. So from home, if you have a system, you monitor your body parameter, or the system will monitor your body parameter, which will be transmitted, live to doctors sitting somewhere. Right? So that's the advantage of this IoT, and next generation medical technology will be based on IoT. So what we have done is, as you see, like we have developing a lot of sensors, and these sensors essentially, target many of these issues, right? Which mainly the doctors need to monitor. For example, mapping body temperature, wound healing monitoring, heart pulse monitoring, voice monitoring, detection of pulse on your human neck, and so on. So there are several applications, and we have been developing, working on specifically different kind of sensors for this system. And the stars, wherever there you see the stars, actually we have sensors in our lab. So what we are doing is translating this research and devices into technology such that some kind of product can be developed. So I'll be talking. I'll try to show some of the sensors that have developed, like flexible temperature sensors, which is ultra fast. It takes only 25 millisecond time to measure the temperature. You remember that the temperature sensor which is used to monitor the body temperature is the thermometer that is used. It takes about a minute and a half time to monitor your temperature. Now we have the sensors that we have developed which takes only milliseconds. So you touch it and your temperature is monitored. So it is as fast and with very high precision. So it's almost like millikelvin precision. This can measure temperature. Similarly, and they have different applications. So we have targeted applications like monitoring body temperature, sleep apnea, chronic obstructive pulmonary disease. So these are systems that we already have developed. Similarly, humidity sensors also. These are all flexible, remember. Flexible also, this also has applications. Similarly, strain sensors. So this we have developed with silver nanowires. It can monitor your heart rate, and also it can continuously monitor the pulse, blood pulse rate. Right. We have developed biosensors, so like HSA protein, that albumin detection sensors, which we already have patented. We have also developed a SARS-CoV-2, that's a COVID detection system, so that work is done. Sensor we have developed. We are in process of submitting patent, and UV sensors for skin disease. So these are all things, self-powered energy devices. So these are all things that we have developed already, and each of these work actually published in high impact journals as well as some papers. this is the sensor, flexible sensor. It measures the temperature, and it can actually monitor your breathing pattern continuously as long as you are using the mask in your mouth, and your breathing pattern will be continuously monitored. Okay, wireless. There is no wire and other things there. So because directly from the mask goes to your Android app, and Android app is connected to IoT server, cloud server. So you are using Amazon cloud server. So there, all this kind of analysis and detection things and stuff. Self-assembled flexible sensors. So these are basically humidity sensors that I was talking, and as you can see here, so this is the photograph of our sensor. It's ultra flexible. It's like 100 micron substrate that the sensors have been developed, and it can very easily mount even close to the wound. So the wound healing mechanism. Normally, doctors try to monitor the humidity concentration, the moisture concentration in the wound area, and it's very important because based on the humidity concentration, they use the medication as well as different kind of bandage that they use depending on what is the humidity concentration or moisture concentration, moisture level of the area of the wound. So they normally use very bulk in this system. So I'll show you some of the figures. But our system will be extremely small. It's like a patch. You connect it, and the data will be connected to your mobile app. Similarly, strain sensor, as you see. So this is the photograph of the sensors, and if you just wrap around your wrist, and so this is the pulse rate. So when blood flow through the artery, the pressure will monitor, and this pressure, as you see, the systole and diastole pressures actually are monitored, and it is monitored continuous. So that's the advantage. And this shape of this pulse wave actually tells you how the different valves is functioning in your body. Right? So there are a lot of things, because the shape of my wave and your pulse wave will not be same, because how your different organs function. So that's something. So now let us start with very fundamental physics, and then come to sensors and then size. So we start with the simple material, and the materials, as you already know, that the material property actually decided by the number. How many electrons are there? So like gold is gold, copper is silver because they have different electrons, number of electrons. And essentially what you have is that what you calculate is the electronic property of the material, right? And from there we calculate the energy band diagram. So you have some of the field state, some of the empty state, and in some of the material has a gap between field state and empty. So the field state means, like for example, if you take the gold, you have one atom has 79 electrons, right? And these 79 electrons are actually accommodated in some electron energy levels inside the material. Now, if you have a crystal or the bulk piece of gold atoms, then let's say if you have n number of gold atoms there, so n into 79, so that many electrons are actually there in the system. You have to accommodate in the energy band diagram. And when you do that, so you'll see that some of the energy levels are filled by the numbers of electrons that they have. Some of the energy levels are actually empty. Now, you exploit these energy levels, empty energy levels, to make a device, because when you make a device, you transfer electrons from battery into the material. In addition to the electrons that you already have in the system, these are all additional electrons that you're trying to inject into the material. And this material has to accommodate these electrons to get some kind of connection and some kind of current. So what we do, and normally we know that we have three different materials. We have a conductor, we have a semiconductor, we have insulator, and based on that, we fabricate devices, right? So we use three different kind of materials. And in case of conductor, so as I said that the field state and empty state, there is no gap for conductor. Semiconductor, there is a small gap, which is somewhere like 2 to 3 electron volts. But if you consider insulators, it has a large gap, so it's greater than 3 electron volt. And these insulators do not conduct, all like insulating polymers, plastics, right? So they do not conduct because they materials. So all you need to do is that after that you fabricate a device, and the device basically connect battery with this material, and it inject electron, additional electron into this material, and this additional electron actually goes to this empty state, right? And this empty state is essentially helps to conduct. Now let us start with the very fundamental thing. So we start with dipole, electric dipole. And the dipole, you know that when you have two positive charge and negative charge separated by distance, then it forms a dipole. And the dipole moment, which we call the P, which is basically charge into separation of the distance, so Q into D. So it has a dipole moment, and then all you do is that if you apply electric field into this dipole, then this dipole actually, this positive charge of the dipole gets some kind of force, and because of this force, what we get is some kind of torque, and this dipole starts polarizing. So if you have a dipole moment, you apply electric field, and that dipole starts polarizing. And when the dipole gets polarized, then you calculate some polarizing component, which is essentially called PZ. Now, if you consider an electric field, if you consider a material and apply electric field, then there is a polarization in it, and this polarization, because of the polarization, that the dielectric constant of the material changes. How does this dielectric constant changes? For example, if epsilon r is the dielectric constant, as you see, you have a PZ square. So if you can change little bit of this polarizing component by electric field or any other means, then the dielectric constant of the material. So if you can fabricate some device where the dielectric constant of the material actually plays significant role in functioning this device property, then you control this polarization of the dipole moments that you have. Then you can actually send something. For example, let's say I have a material which has integrated into the device. All you need to do is that, let's say, increase the temperature, and as you increase the temperature, this polarization changes, and therefore the device property, material property also. So that's the idea. And this is the device that you see here. So it's a couple of materials. As I showed you that you have a conductor, you have semiconductor, you have insulator, and this device has all the complexity integrated in a very specific manner. For example, this gate is metal, then you have an insulator, which, as I said, that the gap is very high, and then I have a semiconductor. In this case, it is organic material, which are also semiconductors, and then source and drain. So these are metal contacts. When you apply some voltage here, then you inject electrons through the metal to semiconductor, and they flow, and you get a current. Now from the back side, when you actually apply another electric field to gate, then actually you apply an electric field here, and this insulator layer can have the permanent dipole moment, as I was talking about. So when you apply electric field, these dipoles, you have, let's say, these arrows are actually dipoles which are randomly distributed in the material. Once you apply electric field, they all get distributed, try to get aligned, and the moment they align all the dipoles, they induce additional charges at this semiconductor and insulator interface, and therefore current actually increases. Right. So that's the simple principle and fundamental physics applied to a device, and then you fabricate device. Of course, the fabrication of device is not very simple because there are several materials you need to put one after another, and then of course the integration of these different materials are challenging. So one needs to do a lot of research on it, and then finally, if you are successful to integrate this material, then you have a device, and based on the selection of the material, this device can be flexible, it can be compressive strain, tensile strain, it can be stretchable also and twistable. So you select a material which actually can help you out to make the device effective. So in our case, we use it's a material called barium titanate, and so it's a very specific phase that we have synthesized, and we integrate this barium titanate into this insulating layer. And then, as I said, that essentially when we hit this barium titanate layer, so its dielectric constant changes because of the polarization. This is a ferroelectric material, so it has a permanent electric dipole. these electric dipoles get polarized, and as a result, its directly constant changes, and therefore the capacitance also changes. As you see, when you increase the temperature for 20 to 50 degrees centigrade, the capacitance of this insulator actually linearly increases. And then if you just measure the current from source to drain, so you have a capacitor somewhere here integrated into the device. And then a capacitor, a current that you measure between source and drain, that's called IDS, so drain to source measured current, which is also linear. So now you see that if you actually make little change of the temperature, your directly constant change, and that make the current change in the device, which is something like 80 nanoampere per degree centigrade. So if you just increase the temperature by 1 degree, then the current change by 80 nanoamperes, that's quite large to measure even the fraction of degree temperature. So if you can measure like 0.1 degree temperature, you can less than that. Still you can measurable current that can be monitored, and you can actually say that how much temperature actually change. So you can measure temperature. That's the simple idea of fabricating a temperature sensor in this material, and then we actually did all sorts of this. I'll quickly go through that. All sort of after we fabricate the device, we characterize the device and characterize in different aspects of this device, like what is the response time, so which you find like 24 milliseconds time, its precision is about millikelvin, and it's actually needs only 1.2 volt operating voltage. So that's very important. So all the flexible wearable electronic device has to be like less than 2 volt power supply requirement, because you cannot carry a bulky battery for that. So this, everything that you need for a wearable device, it has. So as you see here, so this is the temperature sensor, and if you actually tap from the back, the current increases, and you see that these oscillations are essentially in every tap, your current increases and then decreases, current increases. So 70 repeated finger tap, has been monitored, and that's essentially monitoring the temperature of your bottle. We checked how good this sensor is, so we applied these temperature sensors to monitor the temperature fall during anesthesia, so that when we do the anesthesia, even for all mammals, including human beings, so our body temperature falls by a few degrees, 2 to 3 degrees, and we monitor that things in mice, which you can see. So this is our temperature sensors connected on the chest of the mice, and then we have given very mild anesthesia dose. As you see here, so that's the temperature of the mice, body temperature around 36.5 degrees or something, around 37 degrees. And then the moment we give the very mild dose of anesthesia, actually the temperature falls by 2 to 3 degrees. And then you allow these mice to recover. So slowly, as you see here, this portion actually the temperature change, because it's constantly after the anesthesia, it's trying to recover the body temperature, and after something 200-300 second time, it recovers back its original temperature. And then again you have given the second dose, and you see that it's actually changing. So that clearly reflects that this temperature sensors can monitor the change in temperature very precisely, and as I said that almost like millikelvin temperature change it can monitor, and it at very alpha fast rate. So there are so many things can be done with this, because they are all flexible, so you can put it on your body, and then lateral mapping of temperature also, which is necessary in many cases in medical purpose, can be done. Not only that, you can also monitor the breathing pattern. So how do you measure the breathing pattern? So when we inhale and exhale, we just essentially monitor the temperature change of your inhale air and exhale air, and from there we can map your breathing pattern. So that I'll talk about that. Now the sensors that we have developed, which are tested and validated, that it works underwater, and for example here you see that the sensor response is here, which I plotted here. So there are 3 beakers of different temperatures, on 8 degree, 26 degree, and 60 degree. If you constantly dip from one to another, you see that the temperature changes, right? So that's monitored constantly. Similarly, everything such like different pH conditions is monitored, salt condition is monitored, and we confirm that these sensors can be doesn't have any effect on this pH condition or incubator and they monitor the temperature. With our systems, we can actually monitor remotely. So let's say the temperature sensor is wrapped around the wheels, and it's connected to parents' mobile app. So the moment temperature is rising, the parent can get some kind of signal, and they can immediately come and take care of it. So that is one of the applications that we want. Similarly, there are many things like for newborn babies, patients of anesthesia, so they need to monitor temperature, which also can be used. Similarly, the DVT and the basal body temperature change also can be used and real-time monitoring of the body. So these are all applications. So I'll just quickly go through that what we have done. So now you can see that so this is the mask that we have developed with the temperature sensor, and as you see here, so this is your breathing pattern. So simultaneously you can monitor. If you let's say you are sleeping, particularly during the sleep apnea that happens, when you sleep you drop, breathe, and we can actually monitor that. So now let me come to to one of the application system that we have developed, which is called the chronic obstructive pulmonary disease (COPD). And what happens in COPD is like normally what we do when you breathe, we inhale air and it goes inside your lung and then come back. So the temperature of these two airs are actually different, right? And if you can monitor this temperature, then actually you map the pattern, right? So not only the temperature but humidity also. So any temperature sensor or any humidity sensor you can put it to monitor this, right? And then this is necessary for the patients who has difficulty with mainly the people whose respiratory tract is depleted because of many things like because of pollution and of harmful gases, all sort of things. So your respiratory tract gets depleted, and therefore you get less oxygen. And if you actually breathe less oxygen for years, then you develop a lot of difficulty in your body. So one of the things is sleep apnea. So that is also what happens is that when you sleep, the muscle near your airways, so it gets soft and then actually block the air passage. And because of that, you can actually you stop your breathing. So it's basically snoring that we normally say. But this is also a very critical for many people because the sleep apnea is very critical disease in our country, and it leads to a lot of difficulty. As you see that 82% in India are suffering from this sleep apnea, and most of them are actually not diagnosed because you need to go to the sleep lab and to test sleep quality of sleep, and which is very expensive. So currently, even in Kolkata, it takes about 20,000 per sleeping. So you understand that most of them are not diagnosed because you don't go to doctor, and the diagnosis is very expensive. So 80 to 90% adults with sleep apnea remains undiagnosed because there is no system as well, and it's very expensive. So if you look at the COPD, so COPD is again no less than a pandemic which is going on. You see the 53 points. So this is something like 2016 data. 53 million cases in India and 250 million cases worldwide. Those who have COPD, and this one is second highest cause of death in India. After as you see here in 2017 itself, it killed 1 million people. So we see that it's not less than a pandemic that we are actually going through. A lot of people died, and the problem lies here that 20% of the world's COPD patients from India, and 32% of them are actually not curable. So they are called COPD patients. So more than 90% COPD deaths occur in low and middle income countries, so including us. So as you understand the severity of this disease, and it's very expensive. Which you see that the data that I found from the Ministry of Health and Family Welfare website in 2005, the cumulative expenditure from the patient side for COPD test and maintenance is something like 32,000 crores. It's a huge amount of money that flows from patients to different hospitals and clinics. But unfortunately, the gold standard for this detection system is called the spirometer. Only 10% pulmonologists actually use in India spirometer to detect it, because most of the clinics do not have this system, and nevertheless this is the difficulty of analyzing this spirometer data. So because of that, most of the time it's not being used, and you'll be surprising to know that 30% chest physicians, 70% general physicians, 90% general practitioners, and 80% pediatricians, they do not use. So this is again the data as per Chest Research Foundation of India. They do not use spirometer to actually treat COPD patients, and so that is why this number is increasing. As I said, that 32% of them are not curable, so they are COPD part. So they will never get recover from it. So because the treatment is not done properly. This leads this gets enhanced because of COVID. As you know, that the COVID affects your pulmonary tract more, and many of these COVID affected people will be COPD patients in coming years. So this number is going to increase. So we have actually developed this system. So some of the techniques, because of the lack of time, so let me just go to the system and see some of the slides. So we have developed two systems. So one is the smart mask, and which actually we have integrated the sensors that we have developed. So as I said, that this electronics has the Bluetooth connections, which actually talk to mobile app. Mobile app is connected to cloud server, while we actually integrated machine learning algorithms to analyze the data. So everything is connected wirelessly, and the report will be generated on the mobile app. So this can be used at home, so you don't need to visit to clinic, because, and this is very affordable. You don't need to visit to clinic. So at home itself, you can actually use the mask, and the data immediately will be available to the doctor on the clinic. So as you can see, so this is the mobile app that we have developed. So, all the patient's details can be monitored here, and here what you can see is, so this oscillations that you see is a live demonstration of your breathing pattern. In addition to that, your heart rate, your breathe rate, oxygen saturation level, so that's also simultaneously monitored in this system. So that's very important for the guidance. And as you see the data, that's your breathing pattern, which is collected to the cloud server. You see the continuous monitoring of the breathing pattern. So even if you, let's say, during the sleeping, you are using the mask, and some of the breath you draw because of the sleep apnea, right? We'll get to know that what is the severity of this blockage when you sleep, and the moment you have a blockage, you get less oxygen, your oxygen saturation level also will be affected. So we simultaneously monitor the oxygen saturation level, pulse rate. So we get to know that how you sleep and how you breathe over time, and how your body actually responds. Now, if you look at the gold standard, which is, as I said, the spirometer, so as you see, that it's a bulky system, right? And you need to visit the clinic, and it's a bit expensive as well. So whatever parameters, so these are basically the spirometer data, and from there they basically calculate some of the parameters like APB1, APC, right? So these are the parameters that doctor look at, and from so this is the data that normally you get from the spirometer, and just from the shape of this flow volume loop, you can actually predict what is the severity of your obstruction, whether it's mild or severe or restriction. So that can be just do it very easily just by analyzing the shape. But as you understand that analysis of shape is not easy, which we have make it very simple, because we collect the data and we use the machine learning algorithm to analyze the shape, which is very easy. So that process is done in the cloud server. So these are the data from our system. As you see that all the parameters that normally are extracted from your COPD spirometer gold standard, we can also calculate everything that they need from our system. And so this is our flow volume loop, and every parameter can be monitored. So this is the system, or this is the first version we developed. As you see that it's a very small, tiny system, handheld. It has nothing more than that, and you just take it to the mouth and breathe. And so this is our sensor here. This is the measuring electrode. electronics, this is the battery, lithium-ion battery, and everything is integrated in small system. So this is the first version, and this is the latest version that we have developed, which is a handheld methane spirometer. And you breathe here. We have the sensors and electronics here. So you see here the indicator, and you can charge from the back side. So it's like a mobile charge. Everything's like that. So some of the data that we had taken from here. So this is data taken from non-smoker who do not have the disease. As you see the set, but this two data is taken from post-COVID patients. So they already get the respiratory system got affected, and you clearly see the change in their breathing pattern. So just by analyzing, doctor already is analyzing that what kind of problem they have. So just by taking the profile, the doctor can say a lot about that. Okay, so how much time do I have?
Sir, it is up to you, but we are running a little bit late, but it is okay, sir. It is up to you as you.
So 5 minutes.
No problem, sir. Okay, sir.
Okay. Right. So I'll talk about some other applications. So we also have developed this sensor, which actually this is a moisture-enabled device. So it actually absorbs moisture from ambient conditions. It's a protein-based device, and it's harvest energy as well. So now this is a humidity sensor. It measures the humidity also, and it can be used to monitor the wound healing process. So now what we did is that we had taken the very most abundant protein, which is called the gelatin, and gelatin, it absorbs water, that you all know. So when it absorbs water, what happens is that it makes hydrogen bond with the Raipur component of protein that it has, and when it absorbs water, it also splits water. So the water splitting happens like that. So it takes two water molecules and then makes a hydronium ion, which is HCO plus, and then hydroxyl. So this is the splitting of water, and this hydronium, the third hydrogen, which actually connected with oxygen through hydrogen bond, which is not strong. So that happens like here, you have the proton, so that additional hydrogen or proton. So that can actually travel or hop from water molecule to water molecule within gelatin. So if you pump more water molecule into gelatin, then this water layer actually make a connection, the conducting path inside the material, and then you can actually flow current. So gelatin in general is directed, but if you actually it absorbs water, then actually can contact. So this we demonstrated. We have dedicated simple device, and then it absorb water from the ambient condition and make a conducting path, and then you can see that it can actually generate power. So that is also another very important work that we did. That is almost work like a solar cell, right? It's works like a solar cell. The solar cell actually, it absorbs photon from ambient condition, and when it absorbs photon, then it generates some power. Now our device actually absorbs humidity from moisture, and then it can actually generate power, right? So exactly we actually demonstrate that. So 5.5 microwatt per centimeter square power generated in the humidity condition. And what we see is that this also can be used as a moisture-enabled switch, because you see that we are changing the humidity percentage and measuring the current. So up to 55% there is no current flow to the device, because you don't have sufficient number of water molecules into the material such that you can make the conducting path. The moment it reaches 50 or 55% humidity, the current started increasing because the conducting path develops by that. So it can be work like a switch as well. Now just to give you a feeling that how this power generation from moisture works, as you see here, so it's actually going. So this is our device. It absorbs moisture and do that. And you see that in this device, it doesn't have any battery. The back side doesn't have battery. So instead of battery, you have connected our system, and very well it can actually drive this sensor, humidity sensor system. So this can actually give the power, sufficient power. Similarly, you can also with the same system, you can also map the humidity concentration of our body or skin. The skin has moisture, like biology type of moisture, so which can be monitored. Now, as you see here in this case, so this is our moisture sensor developed with this gelatin protein, and the moment you bring your finger very close, you don't have to touch, very close to the sensor, your moisture level of the fingertip is monitored. As you see in this figure, you see that the moisture level is plotted. So at the tip of a finger, your moisture concentration is higher, and then as you move away from it, your sensors measure that the moisture level is little bit lower. So it can very well monitor the moisture level, and which can be used as a moisture sensor, which normally doctors use for monitoring wound healing. So you see the currently used system is really a bulky system, right? You see the sensors they have put here, but the kind of system that we have developed is like in a small flexible, you can in fact paste it. It's like a flexible material just pasted near the wound, and then a small fine size electronics can transfer the data into a mobile app and can give you the humidity concentration, how it change in the healing can be monitored. So with that I stop. So I will not go to the third word. So let me stop because of shortage of time. So the work that we have developed has been reported in Raipur television last year, and it also has endorsed by Ministry of Education, and there is a lot of newspaper also cover this election. So I thank all of you for your kind attention, and I will be ready for any kind of questions that you have. Thank you.
Thank you, sir. Thank you so much. First of all, we are really grateful for being able to for being fortunate enough to listen to your lecture, sir. Your endeavors with flexible electronics, the temperature, pulse monitoring sensors, etc., are really exciting, and I believe that seeing the applications in medical science, especially in various manner with the fast and accurate outcomes, I'm sure the students will get benefited and will be inspired enough to have a part in their future prospects. Personally, sir, I'm really excited also to see the application in COPD, as you have truly mentioned that it is no less than pandemic. Thank you again, sir. So if you allow, we can quickly move to a few questions and address them one by one, sir.
Sure.
Okay. So let me just read out the questions for you. So one question is from Seoshi Chole. She says that can we heal any wound by using this device? I think this refers to one of the earlier slides of you.
Right. Yeah, yes. So we have the sensors that we are working on. It's not completed yet. The sensors can be used. Normally, the moisture, monitoring the moisture level itself actually accelerates the wound healing process. So if, as you know that your moisture, your wound area is too much moisture, like wet all the time, the healing process slow down. So you need a perfect humidity condition near that, and that itself can actually help you to accelerate the healing. So doctor normally in many hospitals after the different kind of critical operations, so they put these sensors to monitor the humidity concentration, moisture level near the wound. And yes, just by controlling humidity also, the wound healing can be accelerated. But you need to measure that. So to control it, you need to measure. So our sensor can be used.
Okay, sir. Thank you, sir. Thank you so much. So Poonam Mondal says, is this applicable only with uniform electric fields or not? Probably this refers to the discussion when we are saying dipole in electric field.
Yes. Normally, when you use the transistor, so that's the device that I was talking about, the field effect thin film transistor. The gate field is uniform because the gate layer is uniformly coated, the insulator layer. So the field is uniform. If you have non-uniform field, then the amount of charge induce will be different place will be different. So your sensitivity may be little bit vary, but it will work. If you are non-uniform, but if uniformity is too less, then device may not come. It should be uniform.
Okay, sir. Thank you, sir. So there is one more question from Vishnu Maiti, who says, is the device very costly or not, considering the poverty level of
No, this is a as I said that it's a affordable use for rural healthcare. It will be few thousand, maybe 2,000-3,000 at the moment, but if we actually make a large scale production, if we can, then the price will be even low. So it is a affordable device. I mean, normally you can keep at home.
Okay, sir. One more question, sir. Can we use this in case of COPD? The device that we are using, that you are using for COPD, can such devices made for, or can be used for tuberculosis as well?
No, tuberculosis we don't have sensor in this system. They need different sensors. So tuberculosis, you monitor different kind of what kind of gas is coming out from your mouth. So that's more on breath analysis, gas analysis. But this system is breathing pattern monitoring system. So it doesn't really analyze the gas, what gas is coming out.
Okay, sir. Okay. I think there is one more question from Spondan Bhattacharya. I think this question is discussed a little bit. Anyways, let me just read out the question. What kind of wound will be recovered by this protein-based device?
This device doesn't actually help to recover. As I mentioned, it monitors moisture, and if you can maintain a specific moisture level in the wound healing, your wound healing process accelerates. So these sensors only monitor the moisture. It's not a medicine or anything, but moisture itself can actually help you out.
I think someone has unmuted himself. I request kindly to mute yourself. Yes, sir.
Yes, so the system doesn't really, accelerate. I mean, it's not a medicine, as I said. It's only monitor the moisture level near the wound area, and if you can maintain the moisture level, then automatically the healing process accelerates. So that's what.
Okay. Thank you so much, sir. The last question probably that we can take is from Shrestha Mujumdar, who says, the gelatin-based flexible electronic devices, are they water and moisture resistant?
No, the gelatin-based device we are only using moisture as to sense moisture. So it has to expose moisture because the purpose is to monitor moisture.
Okay. Thank you so much, sir. And I personally have one question that is for the sake of the students. So if a student is interested in this field, can you please help them to have a clear roadmap how to approach?
I think that's clearly defined. So all you need to do is to motivate yourself to do research, and any of this after your college degree, like you have to do a master's degree, and then all this entrance test that you need to clear, like GATE, NET, to join to PhD program, and then you can join PhD in IITs, IISc. There are several institutes, research institutes, wherever you get chance, and based on your interest, then I think it's all straightforward. Only thing that is necessary is motivation. That yes, research also is something that you can consider. I mean, there are problems. You can listen anywhere that what is the point of this PhD? It takes a long time, and there are no jobs. See, there is a difficulty everywhere. So problem of job is everywhere. So if you just focus that I need to get a job in my village, then you have no job. But if you expose yourself and open up your horizon, then there are plenty of jobs. You need to make yourself ready to get on. Right? There are plenty just look for that I need to be a school teacher, then there are not many school teacher job available, and there is a competition. I mean, you have to be little bit open-minded, come out of your comfort zone, and then take the challenge. So you need to take the challenge, right? So everywhere there is challenge. Nothing in life is not easy, as I said. Even if you think that I get a job in my school, life is settled, it's not the case, right? There are challenges everywhere. So you take a challenge, fix your goal, take a bigger goal in your life, that I need to achieve this. Once you fix your goal, then 80% job is done, because you will be focused to achieve something. Let's say you want to do research. If you make your mind that I am going to do research, then I will not look for job, right? I'll do the job, I'll try to pursue career in research. I mean, there are a lot of opportunities, but there is no easy way. So you have to make yourself ready to get one of these jobs that happens. You have to work hard. You have to motivate yourself and work hard. Then there are opportunities, plenty of opportunities, which you can actually pick up one of them. Okay. Motivation is important. There is no easy way. If you look for an easy way, then you will find that there is no job, there is nothing. So many, and all these negative thoughts will come into mind. That what is the point of this fundamental research, and join the software companies, and these are all things are available. But nothing is easy. Even if you join the software company, life is not easy. You have to challenge in the life. So you have to pick up your, you have to make your mind fix what you want to do, right? Make your mind, be determined, and focus on your work. You get it. That's what I feel.
So thank you so much for your inspiring words, sir. So one last question, because this could be important. This could be an important one, sir. Is there any possibility of pollution caused by these electronic equipments? Asked by Shujan.
No, there is no effect on this pollution. So normally, material gets degraded based on different material gets degraded in the exposure of different kind of gas. But the material that we use, they do not get it. They are all protected from the gas. They are all encapsulated. So there is no direct exposure to different kind of gases are all protected. So that is what I showed, that even if you can drop deep into the water, you can dip into different pH solution, you can dip into salt solution, it measures only temperature. So it's not affected. We made it in that.
Thank you so much, sir. With this, we close the question and answer session, sir. Thank you so much for all your efforts, for all your time, sir. And I really hope that this benefits our students a lot. Thank you so much for your time again, sir.
Thank you.
Okay, sir. So if you allow, we can now move to a second session.
Yes. Yeah, but I have a meeting, so I have to leave. So please excuse me. So.
Okay, sir. Sure, sir. Okay.
Yeah. Thank you. Thank you so much for invitation on.
Thank you, sir. Thank you. On behalf of Department of Physics, Uluberia College, we really appreciate your.
Right. You make offline meetings, not the online.
Yes, sir.
Let the students see things and talk, because online we should come out of it. Okay.
Sure, sir. Sure.
Right.
We are really looking forward to meet you offline, sir. Thank you so much.
Bye. Thank you.
So with this, let us move to our next technical session and welcome Dr. Sabyasachi Ghosh as our honorable resource person. Dr. Ghosh has completed his PhD from Variable Energy Cyclotron Center, Kolkata. He was associated with Bose Institute, Kolkata and Nizer, Odisha as research associate. He has done his postdoctoral research work from UNESP, Sao Paulo, Brazil. Dr. Ghosh was a recipient of D.S. Kothari Postdoctoral Fellowship and was associated with University of Calcutta as well. He has joined IIT Bhilai as Assistant Professor of Physics in May 2018. Dr. Ghosh has his research interests in various topics like high energy nuclear physics, thermal field theory, heavy ion phenomenology, hadronic physics, and so on. He and his team also performed important works with COVID-19 related data to build successful models for further predictions with join us today and deliver your lecture. Sabyasachi sir, if you are ready, then we can start the session.
Thank you, Kinkar. So, my voice is okay or
Yes.
not audible? Okay. Thanks to the organizer and principal, as well as Professor Aditi, and I guess to conduct this webinar series that with Kinkar, there are other fellows also behind this effort. So I would like to thanks to all and giving me this opportunity. So I guess lots of students from graduation level, they are involved as an audience. So I will try my talk more popular way and not the research details of, rather to introduce the research area. So let me present my screen. And also I am muting my video. So my screen are visible now, Kinkar?
Yes, Sabyasachi, it is visible.
Visible. Okay. So let me.
I think you can go to full screen mode.
Okay. Okay. So actually, my talk is the title, so which I missed to write. So it is about the femtoscale physics. I'm going to tell. So actually, it was the previous talk is related with the bio-related as well as physics-related. But this is bit of a different branch, so that is why I maybe in classification wise. So this is one of the branches of physics, which is called the high energy physics, and why these are called, and I will try to introduce the area of the physics, and then gradually I will tell some basic things about the femtoscale physics. So as you know, in our universe, so far our updated scientific knowledge, there are four forces. Actually, if you know, then we can able to explain the many universe's phenomena. So very daring attitude, you can say that with these four forces you can explain everything of the universe. But these are the answer is from the fundamental origins. But when you try to explain some complex system, some complexity will arise. So you have to keep it in that way. So we know the fundamental forces shapes, but now that with these fundamental forces, when the many body things happen, so it might be complicated. But here we will discuss about the basic form of these forces, and probably you the popular books you learn these names of these forces. One is gravitation. So it is a very ancient time. People try to understand what is the nature of this force, and in some sense, with the Newtonian mechanics, it is well understood. Although later it has some dramatic other alternative the formalism through which we understand these things. So that is different things, advanced topics. And another is electromagnetic force. That is also, if people know, probably in the below 10 standard courses classes you introduced. So actually for gravity, actually we know that mass is the reasons. So some candidate have a mass, so they face this force. So mass is the origins. So similarly, there is another fundamental thing which is called the charge, electric charge, and because of that, this electromagnetic force one can face. So actually, I guess in the graduation level, if people cover the electricity and magnetism, the whole things, and I guess when you transit from your old mechanics understanding, gravitations things understanding, and then you jump to the electricity and magnetism, you face some transitions. But later when you cover all those courses, you are acquainted with this, how electricity and magnetism comes and how the force behaves, the Coulomb force, Ampere's law, all those things, Okay. So there are other two forces. So actually, if you see in our daily life, so they are missing. So in our daily life, whatever you can see the natural process even in the astrophysical object. So mostly the gravitations and electricity magnetism force we see. Okay. So in other way, so again, it is a very daring way. You can say whatever the daily life, what you see in your earth, in your universe also, you can easily able to explain with these two forces. Okay, but there is two other forces which only you can see in the femto scale level. So the femto scale, the dimension is 10 to the power minus 15 meter. So it is basically the dimension of the nucleus. So basically our fundamental building block, actually we gradually came to know. Previously we know the molecules, then we know the atoms. Then atoms also we know some structures. So in the core there is a nucleus and electron is orbiting them. So the atom's dimension is roughly, you can say, the angstrom order. It is 10 to the power minus 10, but the nucleus is in the core. Its dimension is very, very small. It's 10 to the power minus 15 meter order. So, and actually, if you see, so it is very really interesting fact that the whole mass of your universe actually basically hidden in the nucleus, because electron mass you roughly can ignore. So if you consider the atom mass means the nucleus mass, and so this pictures is something like that. If you consider the whole India, our country, as a atom dimension, so just equivalently if you think, and in the core there is a city, Allahabad city. So if you consider that as a nucleus, so your picture is something like that. They're all Indian. They are not residing in Jammu Kashmir, not Gujarat, not West Bengal, not South India. So all are concentrated in the Allahabad city. Okay. So this kind of pictures is really odd. So there is something in the Allahabad city because of all India is gathered or highly crowded in that place. So the atomic picture is something like that. So if you really wanted to know the mystery, what is the mystery inside the nucleus, inside the femto scale, then you have to jump on these things, and actually you will discover two new forces, which is the weak interactions and the strong interactions. So in my talk, mostly the strong interactions things I will tell. So I will come gradually. So what is the things? So now thing is that if you just you want to know the femto scale physics. So just think about like Alice in Wonderland. So you have that kind of capacity, and you can shrink your size to this micro level, and you want to see it. Okay, so imaginations wise it is okay, but if you really want to do in the lab, in the experiment, whether it is possible or not. So actually the scientific community is trying to see it, and they have their technology, which is basically accelerator facility they call. With that accelerator facility, they can actually understand, and they can indirectly see these things. And interestingly, this thing is connected with the universe history, how universe is created or all those historical things is encoded in the nucleus. So it is something like you can think that in the human civilizations, that we came from Homo sapiens and there are different stages all we came. So if you analyze our genetic code, then so it is very difficult to encoding these things, decoding these things, but still we came to know how the genetical mutations happen, and every information probably we can get in the gene. So you can say the barcode of the human being. So similarly, the nucleus you can think is a very charming way telling that is the barcode or the genetic code of the universe evolutions. So although it is not very straightforward, but indirectly you can decode the universe evolutions if you really enter or really analyze the nucleus. Just like if you really analyze the genetic things, you can at least say that from where human beings came, okay, from Africa and then other place, and where they migrated. So roughly the history you can say. Similarly, the universe history also, if you try to know the nucleus, there is some hint. So this picture is telling that how the universe created and their evolutions, okay. And there is somewhere some terminology is called quark-gluon plasma. So these things I am going to tell you in details, and from the Big Bang the universe is created, and this is our today's universe. So if you want to reach the history of the universe, so with the experiment actually we can go to the backward time. Okay, so these things I would like to say the students, they can see these Wikipedia links. So there are lots of advanced things are there, but for your self-motivated things, you can try to read all those things. The chronology of the universe is really very interesting. You can spend lots of time to. There will be lots of black books, I understand, but it is really a very beautiful story of the universe. And modern science actually, in such a knowledge or update, I am not telling that they almost know everything, but they sketch the universe history. So from actually Big Bang to today's universe, the whole time span, and they have some knowledge. So for that actually we have to keep in mind some these units. Okay, so I will tell about the millions, billions, so their dimensions, the 10 to the power 4, 5, 6, 8, all those things we have to keep in mind, because we are going to tell about the large time scale things. So again the small time scale things also. So we have to jump from, just like again suddenly in Alice in Wonderland, like we have to be small and suddenly we have to be large. So all those scale we have to be just roaming. Okay, so this scale things we have to keep in mind, because the physics is something quantifying. So quantity, the idea of quantity is always essential. So from the Big Bang to today's universe, we know the age of the universe is in the order of the billions orders. So it's 13 point something billion orders. Okay, and so this is the scale, the log scale. So it is really huge. So with the linear scale you cannot see anything. So in log scale you can zoom in. So different zone. Okay. So let's take, so from the initial that Big Bang is started, and actually, so people are probably interested on the human civilizations, not the universe, because human is more interesting. So if you come to that thing, so these things I am telling about just to get some knowledge about the time axis, then we can understand that at least we have to be shocked that actual evolutions of the universe things, that is really different things, really shocking things, that time axis we have to keep some knowledge. So that is why I am just spending 2 or 3 slides for that. So now, whatever the human civilization, if you want to know, so for before that, the solar system you have to create. So it is roughly, we believe that so this arrow, if you see, so from this arrow, actually is the birth of the sun. So when it's the sun is that created, then the solar system is created. So before that, you can understand. So everything is there, galaxies is there, but galaxies without solar system. So from here, the sun is birth, and also today's we had some astrophysics knowledge, and based on that, so again this I will use the terminology, but you just keep in mind that this astrophysics knowledge or other knowledge, but they are connected with the basic things. Whatever you learn from your college in the blackboard, the classical mechanics, whatever you learn, everything is connected with these advanced things. So what you are learning today is your building block of your future understanding of astrophysics and particle physics and nuclear physics and advanced topics. So today probably it will be a bit of black box, but if you keep on motivating, then you will actually track all those things, and actually you will engage to this kind of research. So that will be my goal of this talk. So from this astrophysical knowledge, we know actually our sun is situated now here. Okay, so and it is, you can say, yeah, and you know that our sun will also someday will die completely. So if you just compare with the human lifetime, that then sun is basically in the young stage. So just you can think, just finish the education and probably searching for a job. So this stage, sun is now situated. So years scale, but at the end, from the, if you go to the back from today's to this way, so in the millions orders actually the human civilizations came, so just 5 million ago. Okay, and okay, so this is the nice YouTube link if you want to see this entire things from the big. It is in Hindi and also English, I guess, available in this link. And there is probably, you people see the nice movies, the Ice Age. So this is somewhere when this stage happens, and you know the real very interesting stories. And before human beings, there was a dinosaur age. So all those things are, if you analyze really in time scale, and if you really remember all those time scale, you really feel very interesting.
I think you started slide number 6 from her. You got muted.
Here, no?
This one.
This one. Okay. So it is now the
question, Dr. Ghosh.
Yes.
Translation. Since I think it's a bandwidth issue, so it will be good if you switch off your video. So that
video, no? Okay.
Yes, that will be.
Yes, that will save some bandwidth as well.
Okay.
Thank you.
Okay. So now I guess okay. So it is in presentation mode. So as I told you, probably you get it that if you the entire universe evolutions, if you convert to the 1 year time, so that will be more, we get some feelings. So that is why people have make some cosmic calendars. So if you visit this Wikipedia link, you will get very interesting things. So I am skipping from January to November. So only the December thing is very interesting, because the life is here. Okay, so as you know, there is a dinosaur age, and suddenly the dinosaur age is disappeared, and so this disappeared happened. If you think in terms of the 1 year's calendar, so it is the 30 Decembers. So this disappear happens. So, and the most interesting things is actually you'll get in the 31st Decembers when there is a hope of the mammal things and the human civilizations. And if you think about the really human civilizations, it was really last 60 seconds of the 31st December. So I'm assuming we are here today. Okay, so with respect to that things, and very interesting that if you say about the religious things, that the Buddha is appeared here, the Muhammad is appeared here, somewhere I guess the Christ, and somewhere here you can also get the Ramayana, all those things. So with knowing this time scale, so what I want to say that my interest zone is to take you with the January in the beginning level, and actually in the real time scale it is really very small time scale. So with the calendar scale, 1 year calendar scale, you cannot see it. So let us come to our original time scale, and what interesting things is happening. So if you so again it is a log time scale I draw, and you cannot see the actual 0 here because log so log actually want to zoom it. So here in 10 to the power minus 12 second in this time scale I pointed out something. So it is something like that. After Big Bang, actually our universe was in some state, and if you want to understand these states, so our today's world is here, okay, and if you consider today's world entire universe rough the times the temperature scale, it is 2.75 Kelvin. So it is a global way to see, and we can think that as time evolves, actually the temperature of the universe goes down. So although I draw in a very simple way, but picture is not so simple because it is not you cannot describe the entire universe with a very simple way, because there are lots of things happen, the galaxy created and other things, there is vacuum also. So maybe we take it in a very rough way, and what is the existing states we know. So in our 10th standard and 12th standard courses, we know that the matter roughly 3 states we introduced, that liquid, solid, and gas. So we have, I guess we have some feelings there what is the matters. So it is some antibody systems, okay, so the atoms, molecules made of that, and they have a mass, okay. So on that antibody systems actually if we increase the temperature, so when it is the form of solid, it can convert to the liquid, and then after some temperature it can convert to the gaseous things. So these things in every matters, these 3 states we know. But if you go beyond that, so then the molecular things actually will break, okay, and actually you will get some 4th state of matters as plasma in some ionized state. So sun is the example of that plasma state, and also so if you go in the below zone, so there is some quantum related things which is the bosons and condensations. So this maybe today's lecture it is not required. So my journey is towards this plasma things, how it comes. So if you understand step by step what is happening, so solid, so the molecules have a very concrete and bound states each other, a very crowded state. And when you go to the liquid, so if you give some heat, okay, so it is the tabletop experiment heat you can give with the Bunsen burner or other things, and then liquid to when it go to the gas. So there are also still it is a molecular state. So the molecules is randomly moving. Okay, so before that in liquid and what solid, they have a bonding. Now bonding is broken. So They are almost free, so randomly moving. Now if you go towards the more temperature, okay, so toward the more temperature, we will see it's very difficult to make some device or you go towards the more temperature. But with the scientific development and the technology, at least we know from how to molecule level to atom level we can disintegrate molecule to atoms, and probably this in our practical lab we use the hydrogen lamp and or other lamp, sodium lamp. So they are mostly in the, so we broke the molecular things and the atom levels, and we disturb the atomic system and we get some spectra. So this temperatures with respect to our this solid, liquid and gas is higher than that, and we will get that kind of the temperature. So this kind of temperature up to that, let's say in the Kelvin, if you say the thousands or mostly 10,000 Kelvin, in the tabletop experiment you can build, but if you really want to disturb the nucleus, okay, and as I promise you to actually the two forces, the weak and strong interactions, it is hidden in the nuclear level, it is in the femto scale. So you have to disturb the nuclear level, and so if you create this temperature, it is really huge, it's a 10 to the power 12 degree Kelvin, then actually you cannot do from the tabletop setup like Bunsen burner or electric things you can do, but with the accelerator facilities you can do. So by colliding to nucleus, so very cool system it is. You can assume that roughly is a temperature zero kind of system with respect to their temperature scale is really different. So if you collide to nucleus, then really huge temperature you can create, and that was the goal of the BNL accelerator setup as well as Large Hadron accelerator setup. So we need the accelerator facilities for that. So now, as I told you, the interesting thing is that the universe history. Okay, so universe history is something like that. From the Big Bang, universe is created, and with a very teeny time scale, lots of drama happens. So again, this drama actually is scientific community speculated, and they are trying to get some experimental evidence also. Okay, so they have some fundamental knowledge, and based on that they track. So how the things is came. Okay, so from Big Bangs is nothing, you can say, from nothing to something how it came. So with the energy to materialize thing equal to mc square relations we know. So how it came, so that story is there. As I told you, the interesting stories you can see in the Wikipedia link, that earlier slide I have mentioned it, those slides. So you can spend some time and you will get very exciting things. So if you are motivated on these directions, and my interest is to that domains where the entire universe was in the quark and gluon, made of quark and gluon. So actually you can understand. So actually there is a huge energy is in a singular and it is plus. Actually Big Bangs mean that. So scientific community mean that, and then from energy to materialize when happens, the first building block is basically quarks. So that things I will come why the quarks or something. So this we believe that our universe was in the quark gluon plasma state, and its temperature is in energy scale is of the order of 100 or 400 mega electron volt. If you convert to the Kelvin scale, it is 10 to the power 12 degree Kelvin. Now these things with the help of the accelerator facilities, by colliding to nucleus, we can able to create. Okay, and it is when people indirectly measure that kind of huge temperature samples, and they have made it. So we have to be careful that actually nucleus dimension is a Fermi order, so it is very teeny in space. So whatever the medium we are creating artificially in accelerator, it is very teeny in space and also teeny in time also. It's very small time we can create. And after they indirectly measures that medium they have created, so it is goes to the Greenwich Book record that it is the highest man-made temperature. It's 10 to the power 12 degree Kelvin. So artificially in the lab, and actually we have reached the baby universe that state. Okay, so there are lots of goal that to understand what is happening inside the nucleus. Okay, so as I told, if you with your imaginations, if you go as a Alice in Wonderland and if you enter to the nucleus, there are lots of things happening which is very odd to do with our normal things. Okay, so this way actually I jump to the quark-gluon plasma, but actually when you enter to the particle physics things, the very interesting thing is that if you know the light is basically the electromagnetic spectrum, so electromagnetic radiations, and if you increase the frequency, okay, and then there is some frequency, the energy is sufficient enough, they can convert it to the mass with the help of the Einstein, going to the Einstein's energy mass relations. Okay, so actually in the accelerator facilities, people really create these things, whatever we learn from our textbook. So it is possible, but we have to know the range. So range is here. Okay, so beyond the X-ray, actually we can able to see. So if you really want to know the nucleus, what is inside the nucleus, you have to go to the higher energy. So that is why this branch is called the high energy physics. So with respect to that, so after X-ray, so when you go to the gamma ray domain, so this energy scale is basically the high energy domain. But before gamma ray, you know about all those X-rays, visible range, the infrared, radio waves, all are the spectrum of light, and they have the different domain of physics. Okay, so our interest is here, the high energy domain. So that we want to disturb the nucleus. So if you want to know the accelerator facility, so maybe very kidding way you can think that our tube light that is also is basically the accelerator, because here electron is accelerating, but only thing is that energy is very small, it is 220 volt, and what happens during their journey, they're accelerating, they face to the molecules or atoms of this gas. Okay, so whatever inside the tube light. So these atoms. Okay, so this electron is probing, and so we know that is the accelerator voltage is roughly 220, 100 volt. So with that range, actually they can probe. As I told you, so this is the spirit of if you want to be Alice in Wonderland kind of, you want to go the microscopic domain, then the idea is that you have to increase the energy. So when you have a 220 volt energy, when let's say I'm electron, I'm trying to probe the microscopic domain. So at that times you can probe only the valence electron. Okay, so valence level electron. So probably people know about the quantum mechanics. There is some energy level concept of Bohr atomic model. So from there, actually, roughly, I'm not going to deep, but roughly you can see the valence level electron have some patterns, and then if you disturb this valence level electron, so you can gauge the if you disturb it, then you can gauge the energy. Okay, so the radiations, and that radiations goes to the visible range. Okay, so because that you are getting the visible range light from the tube light. Okay, because you are disturbing the valence level electron. Okay, with the energy of 220 volt electron. So now if you want go more deep, okay, so you can disturb the inner level electron also. So that was done by this fellow. So this is very interesting fellow, the Ronchen. So accidentally discovered. So he actually accidentally did this, just increasing the potential. So increasing, so instead of 220 volts, a thousands volt, okay, kilo order electron volt if you use, then what happens? So then if you disturb this inner level electron, actually you will get the X-ray. And problem is that X-ray you cannot see. This is not the visible range. So at the time was a very nice conversation. So he told, I have discovered something, but what I discovered I don't know. So that is why the X-ray is in the nomenclature. So now if you go to beyond the kilo electron volt, so if you go to the mega electron volt, mega means 10 to the power 6 electron volt, then actually you are able to reach the welcome to the nuclear physics scale. So this is the Femto scale, the Fermi order. So 10 to the power minus 15 meter. Okay, and actually here when they try to understand these things, actually the definitions of force completely changes. So previously our definitions of the force is very more physical kind of, so that there is a force of line, they attract, they repel or something. But now, so I put the photos of the Richard Feynman, but there are other scientists also to develop these things. So they tell that force between this fellow and that fellow is coming because of exchange of particle, exchange of that informations. So some fellow is there, is a very ghost stage or virtual stage. So he is a messenger. So he will tell about the electron informations to the protons. Okay, for any two candidate things. So if you tell about some good things, then they feel attracted. If they tell about the bad things, then they feel something like that. So it is a very advanced mathematical way it's developed, which is called the quantum field theory. So so for that you have to go from classical then to quantum, then to also the classical field theory, then merge this quantum and classical field, and also enter the relativistic, special theory relativistic idea. Then merging of all those things, actually this theory developed, and they come to this conclusion: force is nothing, and there is a messenger who actually exchange the information. Because of that, you are feeling the force. So this, when people, scientific community entered this nuclear domain, so actually the Rutherford is the pioneering scientist to make it that kind of accelerator, and they disturb the nucleus. So what is happening inside the nucleus, we want to know. Okay, and we know the nucleus is made of only neutron and protons. Okay, so there is no other fellow. So we completely know that how many neutron and how many proton. But when you disturb the nucleus, it is very surprising things that we see there are some other particles there, and who are those other particles? So later people realize actually they are basically the messengers. As I told you, that any force there needs some messengers. So for nuclear force there are lots of messengers. Okay, and actually these messengers, if you disturb that messengers, they are in virtual state, but if you really hit the nucleus with the accelerator facilities, that messengers you can get in a real form. So these are the names, so Greek letters, rho, k, phi, pi. So there is lots of the particles comes, and they are documented in a, you can say, dictionary is called the particle data book. Okay, so just like the chemistry people know, so this fundamental elements, so it's 100 elements, and with the help of this 100 element, they can create many complex things. Okay, but they are the basic building blocks. So this is they are basically taking the permutations and combinations of these elements and create the all chemical compositions. So similarly, in the particle data books, there are all those particles informations are there, but we realize there are fundamental particles inside all those messengers, tail or protons, neutrons, and they are made of basically quarks. So far, people get the information why there is 6 quarks available, although U and D are basically the fundamental quark to make and the neutron and protons. These other quarks actually it's not required for build the neutron and protons, but all those quarks are also possible if you really disturb the nucleus. Everything so all possible permutations and combinations of these quarks and they make, so we commonly call the hadrons. So the mesons and baryons are two possible things. But you can roughly say they are basically the messengers. So apart from the neutron protons, they are hidden. But if you heat it, you can create all those particles. So as I told you, if you really know the nuclear, what happening in the Femto scale, in the nuclear physics, you need beyond mega electron volt scale energy. So in our country-wise, national status is that we have a accelerator facilities in BCC, EIP, but there, as you know, to make this R&D is really need some tedious jobs. So what we reach is a few mega electron volt level. So still it is sufficient to disturb the nucleus, and you can say some nuclear physics informations. But world is very rich, so that is why they reach to the very large energy scale with the collaborating with different country. India is also the part of this the collaborations, and they reach. You see here India is few mega electron volt, but they reach the giga electron volt and 5.5 tera electron volt in large electron collider. So when you so if the questions comes, so you are trying to probe the nucleus, so but what is the use of the human civilizations? Okay, so it's for basic understanding. It is okay, but so this way it is not created. But if you see that so it is the source of energy, so, and the human civilizations is searching for the energy, and they already have the thermal power and other power. But if you know the nuclear and if you control the nuclear power, then you can really able to use this power also. And this is really some jump scale. Okay, so whatever energy you are using, so if you analyze the special theory of relativity relations, so we are habituated the energy is basically p square by 2m, that or half mv square. Okay, so that energy is in the non-relativistic energy relations, and whatever the thermal power and other power you are using, so it is in that domain. Okay, we never reach to the relativistic relations, but with the nuclear power you can reach to the relativistic relations. And the relativistic relations is one very interesting thing is that this m naught c square that was not known to our before special theory of relativity, the rest mass energy. So it is some hidden energy. So every candidate have a mass. Okay, and mass you can extract the entire mass to the energy that was very unknown before the special theory of relativity. But relativity is saying that. So actually, if you calculate, so a chalk, if you convert this mass to the energy, it is sufficient to destroy the entire world. Okay, so if you really do the calculations, it's nothing just m naught and c square. If you do, then the entire energy you can use. Okay, so chalk has a really very big m naught. So with respect to the nucleus, so many nucleuses there. So now. But unfortunately, or maybe fortunately, nature is not built like that. Nature don't allow you to extract the chalk entire mass to convert it. If it is allowed, then world is not survive. So they allow only if you enter to the nuclear domain, only when it can able to extract, but still not completely extract. There is some particular nuclear reaction. So which you can do. So it is, you can think this is one of the applications of this nuclear physics. And doing this sound business, actually, this is very interesting news that the byproduct of basic science. So sound is the Large Hadron Colliders, so it is located in the sun. So their main aim is to know what is inside the nucleus. But so this is a very big project, and when they do these things, they face some problem that there are lots of data, and data we have to transfer to other area without going physically. Okay, so through online, not whether we can do something. Okay, and based on this requirement, so this wave things is discovered, and these are the employee of the sound. So it is based on the necessary it built, but nowadays it is the main entertainment of our daily life. Without wave, without dot, we are very hopeless. Okay. So this basic science, although it is not designed with a very specific things, but it's a byproduct. Discovery is also what they have a social impact. Okay, so let me summarize. So just I have introduced basically to this research area. So my summary may be tell you that the gross way the quarks is the building block of the universe. So if you analyze from molecules to atoms to nucleus to protons to the fundamental quark level, and after Big Bang, universe was in the quark-gluon plasma state, okay, and that can be larger than collider sun accelerator facility can produce this artificially this baby universe. And keeping focus center on the baby universe, there are many experimental and theoretical groups in different corners of the world are engaged in the research, but unfortunately, I have not touched anything about this. And after summary, maybe 2 slides more, I want to say that cautions about the language and caution about the twist concept. With this, when you go to this journey, you try to want to know the nuclear physics, what is happening in the inside Femto scale. So there is the mathematics is your main language, but relativity, special theory, relativity, quantum field theory, all those that you can say some specialized language you have to know, and some twisting concept also, that very odd things happening, time is dilated, length is contracted, and theoretically also the force definitions also, you are not touching to each other, just like in mobile WhatsApp, you are chatting and you are facing angry, or you are feeling love, or whatever the attractions or repulsion happening, just through because of the exchange of the particles. So some kind of this that language is in your future journey. It is waiting for you if you are really interested with that. So recommendation is it is waiting. So you have to jump in to mathematics as well as the twist concept. And so maybe this slide I'm not telling. So it is waiting for you. So if you are really motivated, and this is the sound T-shirt that were the Lagrangian, and they have written, and this Lagrangian tell about the 4 forces. So which basically you can think as a daring attitude, as 4 forces you are telling just in your T-shirt. So if you want to know this, then actually this language-wise jump you have to go, and then probably you reach, and then probably you will understand this. So telling that, maybe I'm stopping here, and thank you to everyone.
Thank you, Dr. Sabyasachi Ghosh. We are really grateful that you could manage some time from your end to come over here and discuss the very important things with all of us. Your talk that incorporated even the topics of relativity, how that make an impact in the course of nuclear physics or the high energy physics. These are really interesting, and I sincerely hope that this make an impact in the future inspirations for the students. And your connection, definitely one thing that that was very interesting is the connection with the evolution of human race and back to the evolution of the universe. That was really interesting, and especially the nuclear physics that we used as a barcode or the generic code for the universe. I'm definitely going to use in the next course of my nuclear physics. I'm definitely going to use that if you allow me.
Yes.
Okay, so with that, let me just quickly move on to a few questions as the time is very short. The first question was from Shrestha Mojumdar. She wanted to ask what actually happened. That is a very interesting question. What actually happened at the time of hadronization? And personally, I would like to add to that also that you can please elaborate a little bit on the scale of scale of hydrodynamics.
Yes. So this is very complicated things, but very crude way or maybe popular way. I can say in this way that so this strong force, what do we say? It is inside between two quarks or three quarks, okay, and they are basically separated of the order of Fermi space difference. So generally, whatever the force we know with respect to their strong force is really odd. So generally, even the human beings also, two friends, if it is close to each other, so they are attracted, okay, or maybe repel. But whatever if you don't think about the attraction or repulsion, the force is magnitude is larger. Even two magnet, when you come close, the magnitude is larger. But when you take far, so magnitude is decreased. So it is general tendency. But strong force is completely different. When two quark, so they are go far, then attraction become larger. But when they come closer, the attraction become weak. So when they are out of sight, they are not going out of mind. Their attractions become more. Okay, so it's really very odd in there. And then, so when this quark-gluon plasma is created, so when it expands, so two quark is basically go far. So at that time, they not remain as a quark, so they create the hadrons. Okay, so they create some bound system, family. Okay, and then it happens. So this how it is happens from a microscopic force wise, it is very difficult. But there is some model calculations through which actually we can see. But if questions is actually happens at time, what time is it? Question in there?
Yes, at time of what is the phenomena behind hadronization? What happens during the hadronization?
Okay. So it is just quark to convert to the hadrons. So that is the problem is that this is very natural process, and that is why free quark we cannot get, just like free electron we can get. Okay, but if we are actually disturbing the nucleus and we are creating artificially very small time the quark-gluon plasma, but it will not sustain because immediately it hadronizes and we will see basically the hadrons. So this way it comes.
Right. There is one question from Aniket Mondol who wanted to ask what is weak interaction?
So actually these interactions, four interactions or four forces we tell, so they are different because of their magnitude, and as I told, the messenger is important. That suppose A and B are feel attract or repel, so there is a messenger C. Okay, so then so we actually classified the four forces in that way. Which messenger is responsible and which informations also they are carrying. For electromagnetic field, the information is basically electric charge. Okay, so electric charge is basically carrying the information, but messenger is photon. Okay, so they build some if there is a charge particle and how photon take the information. So there is a theory in quantum field theory, it is called quantum electrodynamics. So they describe the electricity and electromagnetic force. So similarly for weak interactions, the messenger is W plus, W minus and Z0. There is three messengers. Okay, and they take you can say some information which is called weak charge. So you have to put some name, and why weak terminology came? Because of their strength wise, they have some classifications. So that is with respect to strong, it is weak. So that is why it is. So weak force. So it has some very rigorous background theory. So you can say that as a quantum flavor dynamics. Okay, so flavor is changing. There is some descriptions of that. But because of these messengers and because of the which quantity is responsible for that, just like mass is responsible for the gravity, okay, or electromagnetic, that charge is responsible. Similarly, weak charge is responsible, and from messengers is changing. Just like strong force also, the strong, the color charge is responsible, and gluon is exchanging between them. So, in smaller is.
Yes, actually, these things needs a lot of time to discuss.
Yes.
Anyway, so let us move on to the next question. It says, it is from Shrestha Mujumdar, who says, what is about...
Okay, so what is the twist concept? So I actually...
Yes.
So actually, the twist terminology I used because when you transit now, so in our college time we discuss among the friend, and we generally tell this way that after quantum mechanics and before quantum mechanics we should take a photo. So what is the changes of our faces, or so we feel very stressed, our things is how the concept is changing. So really there are some things comes, although we are acquainted with this journey, but if you see that when you go from non-relativistic idea to relativistic idea, really some twist concept come. For example, this time dilation concept. So this time interval. So I am giving the lectures 1 hour here, someone giving the lecture in US 1 hour. It should be same, but someone is moving because of the velocity. It 1 hour may be dilated. So that is very odd things from the Newtonian mechanics. But in special theory relativity, we say it comes. Okay, even the velocity additions is also very magic additions. Generally, the relative velocity when you do that, someone is moving and in the train, and someone is inside the train with a v1 velocity, and train is v2. So generally it adds v1 plus v2. But relativity provides us a magic velocity additions. So it will add, but magically it will never cross the sea. So this kind of concept when you learn the special theory relativity, then when you learn the quantum mechanics, then when you learn the quantum physics, there are lots of twisting concepts come. Twisting in the sense that our brain is acquainted with the classical things because 10 years or 12 years you spend the times in the classical concept. But when you enter to the graduation level, the special theory relativity, quantum, and other things will come, and then actually you face this twisting things. So this twisting term I use for that.
Okay. Thank you, sir. Thank you. There is one more question. I hear. Okay. There is one thing from Suchan Mukherjee who says, I hear about scientists are trying to make artificial sun.
Yes.
That is very
So this is not, I cannot say more rigorously, but so far I also know, just like you. So, but from basic science you can understand. So if you learn the nuclear physics, so in sun what is happening, you know that nuclear fusion. So as I told you that Einstein relativity, that m naught c square, if you want to use it, so there is some reactions, nuclear reactions. One is fission, another is fusion. So in sun it is happening if you fuse two hydrogens and during the helium forming, that energy. So again, it is not entire rest mass energy you are going to use. So we don't have any that kind of nature don't allow. Nature don't allow that kind of things. But some mass difference part, it can be converted to the energy. So sun, whatever energy you are getting because of the process, hydrogen to helium process, the fusion process. So if we can manage that kind of process in Earth. So then we can get the same power. So it is a nuclear power we can able to get. So this tokamak is basically designed for that. And there is some challenge in artificially creating that things. So not the reaction wise, but mainly a container where you put it, that reactions or something. So that details I'm not aware, but maybe that we have a institute, IPR, Plasma Research Institute. So there is a collaborator of that game. So maybe if you search get some scientists there, you can get more better pictures, and also I guess you get some literature in the Google also. Okay, so there is a next question. So my voice is okay now? Okay. So maybe next questions. Electrodynamics of proton, quantum level, it is visible. Photon particle move from the charge to another charge. So thing is that so actually the messengers, when inside some microscopic system, let's say in atomic system, the electron is revolving, and in the nucleus there is a proton. So basically, because proton have a positive charge and electron have a negative charge, so in between photon is exchanging. So previously our understanding is basically Coulomb force. Information we know that this charge into that charge divided by r square. So this way force we define. But more delicate way, in quantum electrodynamics, they describe in this way. So there is a virtual photon is exchanging. Okay, so that photon you cannot see, but when you disturb so this atomic system, so actually if you have two lights, so the electron is disturbing when the atoms. So at that times actually they disturb the system, the atomic system, and that virtual photon actually come as a real photon, and that real photon actually you are seeing from the blue light. That is why you are getting light. So in this room also you are getting light. But if you don't disturb, so if you switch off, if you don't switch on, then electron will not disturb the atoms. You will not get the light. So at that time, also photons is exchanging in between protons and electrons, because otherwise how they bound. Okay, so this is, you can say, some different way to understanding the forces, and they have some historically evolution how it came, and probably you will convince probably this is the more better way to understand the force. So this photons things actually in real life also you see, so you may not trust, but W plus minus Z0, all those particles I am telling for weak interactions, so that things you never see. Okay, so and also there is in the nuclear force is a bit of complicated versions of strong interaction. So there also the pion and low mesons, they are exchanging. They never actually they are virtual state. But if you in the accelerator, if you hit the nucleus, the W plus minus Z0 particle really come as a real particle, and people have detected. So then people have get more trusted. Okay, so whatever the theory they are proposing, okay, so it was Yukawa first proposed that pion is exchanging between nucleus, but when pion is detected, people really become soft. So they respect that philosopher how we understand, so that some particle with that mass is they are exchanging before detecting, before experimentally known. So that this way actually particle physics actually evolved, and if you when you enter to the particle physics subject, you will see it's really very interesting subject, and your understanding and everything will be changed.
Thank you, Shobhit. I'm extremely sorry. In between, I got disconnected because of the network issue. I'm extremely sorry. So since time is very short, we are not being able to take many more questions, but I'm sure there will be definitely many more questions coming up.
So they can email me also later also.
Yes, if you allow, we can circulate your email ID to the participants.
Yes, and also the slide also you can see. So everything is okay. Okay.
Thank you so much. Thank you so much, Subhajita. Last thing, just I want to take up for the sake of the students is how can they approach to get some project or internship for the how it is applicable for the BSc students in IIT.
Okay. So actually, there is a trend in ISER. So there is many ISER institute. So their thought process goes in that way. So during the BSMS course, the BSc and MSc, the 5 years or 4 year courses, they do this internship thing. And but they are basically probably some people get fellowship, and that is why they can manage this thing that they can travel and hostel accommodation, all those things they can manage. But that is the problem for college people. So although they also I guess get the summer vacation time or winter vacation time, so they can use this time. So by approaching to different faculties, or if they have some different interest and practice, so they can surface to in the internet everything. So they can understand. So they can explore their which direction they have interest, they can approach. So now it is very faculty dependent things whether they have time to take the internship or not. For my case, I am always generally encouraged to take the internship. So this summers also already I guess in audience also there here. Some ISER Raipur students and some N93G in ISERs and ISER Uluberia. So they are coming just 1 month things, they just cultivate this kind of things. Although it is not I can say the complete picture, but they get some flavor and they can get more motivated. And even also beside Bhilai, I guess from West Bengal is very far. Even also within West Bengal also there is lots of place. Even in the college also, even I can recommend that Kumar is a very bright student in the research. So I guess in the nearest college also that kind of, and their colleagues also. So there also they can create that kind of environment, and if they need some help, some particular topics, if they interested to know, so then I may also connect with them. So nearest those Bengal which are the good faculty, if we touch and if we go, let's say offline, just spend some 1 month time, they can really enter to these things, and they can be motivated for the future research and other things. Okay.
Thank you, Dr. Ghosh. It was really helpful to listen to you, and I am completely sure that this will motivate our students enough to get a future career in nuclear particle physics and high energy physics in this direction. Thank you so much, Dr. Ghosh. Since the time is very short, a quick announcement to the participants that the feedback form will be circulated to you. Please fill it up in the chat box itself. Please fill it up by 11:59 p.m. today. And before going into the vote of thanks, I'd like to make one more announcement that already has been made, that the presentation slides and the email ID of Dr. Sabyasachi Ghosh will be circulated to you. You can write in directly if you have any question in mind. Thank you so much once again, Dr. Sabyasachi Ghosh. May I now request our head of the department, Dr. Rahman, to kindly step forward and deliver the vote of thanks. Yes, sir.
Am I audible? Yes. Am I audible?
Yes, you are audible.
So, a warm and graceful afternoon to respected speakers, Honorable Principal Sir, IQAC Coordinator, dear participants and my colleagues. It's a privilege to propose a vote of thanks and acknowledge the contribution of those who made this event possible. On behalf of organizing committee, I extend my hearty thanks to respected speakers who spared their time from busy schedules and delivered talks with us, especially our students in near future. Your deep and intellectual way of imparting knowledge had added favor to this event. Special mention to our Honorable Principal Sir and IQAC convener who acted as a positive catalyst which helped us to do our best. I am thankful to Teachers Council Secretary Dr. Shikshankar Das for technical support. I would also like to express my sincere thanks to the joint conveners for executing the event possible. Department of Physics, Uluberia College has been fortunate enough to be backed by a number of proactive and experienced teachers who helped the conveners in many ways in need. I extend my sincere gratitude to the participants from different institutions for their active cooperation and support. Last but not the least, students are inevitable for this event. Without their encouragement, this webinar would not have been possible. If the students can get something and motivate themselves out of today's discussion, we feel that the purpose of today's webinar is successful. Thank you all. Have a great day. Thank you.
Thank you, our HOD sir. So it is now time for us to end the webinar. We again on behalf of Department of Physics, thank you all for being with us for the last few hours. And here we end our seminar. Looking forward to see you all again soon. Thank you, Dr. Ghosh, for being with us and delivering the lecture. Thank you, everyone. So, can we end here?
Yes, please.
The recording has stopped.